Okay, this video is for Mrs. Cucci's College Now Pre-Calculus class. We are on file 2.3, the composition of functions. Okay, so make sure you have that file open and you're ready to go. Okay, so today, by the end of the lesson, you're going to be able to find composition of two functions and the domain of the composition. And you're going to be able to decompose a function as a composition of two functions. Now, we did composition of functions last year. We did not do decomposition. So that's going to be something that's a little bit new. Okay. In real world situations, it's not uncommon for the output of a function to depend on some input that is itself an output of another function. An example of that is the amount a person pays in state income tax usually depends on the amount of adjusted gross income that the person's federal tax return, which in turn depends on his or her annual earnings. So these functions are called composite functions. It's basically when you're taking two things together, two separate things, and we're putting them together and creating something new. Okay. So let's talk chem. We need a formula to convert Fahrenheit to Kelvin. That formula is C of T equals 5/9 times T minus 32. That gives the Celsius temperature, C of T, that corresponds to the Fahrenheit temperature, T. The formula to turn that one over from Kelvin, Kelvin to Celsius is K of C of T equals C of T plus 273. And that gives us our Kelvin. All right, so basically to go from Fahrenheit to Kelvin, it's a two-step process. You would first have to convert it to Celsius and then from Celsius to Kelvin. So we want to make it easier for us to kind of do that. So before we do that, we're going to take a peek at how we actually work with this. Pardon me. So if I wanted to take, if we want to take 50 degrees Fahrenheit and turn that into Kelvin, we're going to use our formula. Okay? We're going to start with our first piece, which is our formula 5/9 times T minus 32. Okay? So C of 50 equals 5/9. We're going to plug in that 50 minus 32. So we get 5/9 times 18, which is 10 degrees Celsius. So now we've converted from 50 degrees Fahrenheit to 10 degrees Celsius. Okay? From Celsius, we're going to go ahead and change that to Kelvin units. So we take that and we plug it into our K of C of X function. So K of C of 50, which is our Fahrenheit. So we have K of 10, because there's our Celsius, right, equals 10 plus 273. And that gives us 283 Kelvin units. So it was this two-step process. We had to go from Fahrenheit to Celsius and Celsius to Kelvin. Now, this would be a big pain in the rear if you had to do this every single time you wanted to go and find Kelvin units. So there has to be a way to make this into a one-step problem, and there totally is, okay? All you have to do is find the composition of the two functions. All right, so convert 32 degrees, the freezing point of water, to kelvins. All right, so what we're going to do is we are going to take and find that composition, okay? We want K of C of T. That's going to make it much easier for us to convert to kelvins. So what we have to remember is that C of T is 5/9 T minus 32. And, pardon me, K of C of T is C of T plus 273. Okay, so we're going to take these and put them together. We're going to plug this C of T in for C of T. So our formula becomes K of C of T equals 5/9 times T minus 32 plus 273. Now this makes it a one-step problem. Okay? So we can distribute that out and make it look pretty. K of C of T equals 5/9 T minus 160 over 9 plus 273, or K of C of T equals 5t plus 2297 over 9. Okay? So there's our pretty formula. So now it's very simple to take and convert 32 degrees Fahrenheit to kelvins. Okay? So all we have to do here is plug that 32 in for our T, which stands for temperature, in Fahrenheit. All right? So we're going to real quick go ahead and do that. And I'm going to use just a scratch pad to make it a little bit easier for myself. I know I normally don't let you use it. Please insert a calculator page. You'd be better off doing that. As a matter of fact, I should be doing that. Control I, add calculator. So we want to go from 32 degrees to kelvins. So we're going to do our equation. Actually, T store 32 degrees. And then our equation, 5t plus 2297 over 9. So 32 degrees Fahrenheit converts to 273 degrees Kelvin. Or 273 Kelvin units, I should say. Okay? So with that composition function, it becomes quite simple. Okay, so convert 212 degrees, the boiling point of water, to kelvins. So again, 212 degrees Kelvin units. T is going to be stored as 212. We're going to borrow my function. And we get 373 Kelvin units. So once you have that composition function, this becomes very simple. Okay? So I guess we already made it easier. You're probably thinking, Mrs. Cucci, there must be an easier way. Of course there is. Simply perform the composition of the two functions, and now you have your one-step process, which we already took you through. Okay? So composition of functions, the composite function f of g, that's another way to write it, the composition of f and g, is defined as f of g of x equals f of g of x. So you're going to see it written both ways. Where x is in the domain of g and g of x is in the domain of f. So last year we said what's eating what, right? We said we had the big monster and in its belly was the g. So the g went into the f, right? So we're going to use that again this year just to remember what order we work in. So we always work from right to left. From right to left. Okay. All right, so given that f of x equals 2x minus 5 and g of x equals x squared minus 3x plus 8, find the following, f of g of x and g of f of x. So we're going to do both. We're going to start with f of g of x. And you're going to notice that I'm going to make sure that I continue my notation all the way down with each and every step, and I expect you to do that as well. Okay? So f of g of x, that means that we're going to be taking g and placing it in the x for f. So we're taking all of g, and we're placing it in to the x of f of x. Okay? So 2 times x squared minus 3x plus 8 minus 5. Okay? Don't forget to use all of the function. The only thing that's changing is this piece right here, which originally was my x. You do want to simplify these out. So we're going to distribute. And then combine like terms. And there's your composition function f of g of x. Okay? So we worked from right to the left. G went into f. Okay? Now the next one's a little bit different. This is g of f of x. So instead of g going into f, we're going to be taking f and putting it into g. Okay? So I'm going to erase this. And we're going to work the other direction. This time, f is going in for the x in g. And notice there's two x's that we have to plug it into for this one. Okay, you want to make sure that it gets plugged in for every single x. Okay, so this becomes 2x minus 5 squared minus 3 times 2x minus 5 plus 8. And again, we're bringing down this notation each and every time. We're going to FOIL that out. 4x squared minus 20x plus 25 minus 6x plus 15 plus 8. And remember, this does have to be FOILed, and that's exactly what I did. I just did it in my head and didn't show that step. Okay? Combine my like terms. We have 4x squared, negative 20x, minus 6x gives us minus 26x, plus 25 plus 15 gives us 40 plus 8 is 48. So, my f of g of x if you remember, and I'll jot it down for you so we can see them side by side, was 2x squared minus 6x plus 11. My g of f of x is 4x squared minus 26x plus 48. Notice they are not the same. Okay, the composition of functions are not equivalent when you go from one to the other. So if you're asking for both, you can't give me the same thing twice. They are very different. Okay? Okay. Given f of x equals 2x minus 5 and g of x equals x squared minus 3x plus 8, find the following: f of g of 7 and g of f of 7. So chances are, if I did the composition of functions like I did in the last one, they would not be the same thing. So chances are, if I evaluate, which is what I'm doing here, we're not going to get the same value at the end. So you do have to do them separately. F of g of 7 means, again, we're working from right to left. So the first thing we're going to do is we're going to find g of 7. And all that is substitution. You guys know very well how to do this. And we get a value of 49 minus 21 plus 8, which gives us 36. And now because we have this right here, we know what g of 7 is. We're going to plug that in for f. So f of 36. 2 times 36, oops, minus 5, which is going to give us a value of 67. Okay, so there's f of g of 7. So now g of f of 7, we're going to follow that same kind of process, except instead of finding g of 7 first, we're going to find f of 7. So f of 7 is 2 times 7 minus 5, which gives us a value of 9. And now we take that value of 9 and we plug it in for g. 9 squared minus 3 times 9 plus 8. So 81 minus 27 plus 8. And we get a value of 62. Okay? So therefore g of f of 7 equals 62. So that's just evaluating. And you guys did learn how to use the define function on the calculator last year. That will walk you through this process. Okay? All right, given that f of x equals 2x minus 5 and g of x equals x squared minus 3x plus 8, find the following: g of 1. Okay, so we are using the same function twice. Okay, we start again right to left, and we're going to find g of 1 to start. Well, g of 1 1 squared minus 3 times 1 plus 8. G of 1 equals 1 minus 3 plus 8, which gives us a value of 6. So now that we know what G of 1 equals, we plug that in. G of 6. 6 squared minus 3 times 6 plus 8. 36 minus 18 plus 8 gives us a value of 26. So G of 1 equals 26. All right, so hopefully you're feeling pretty comfortable with evaluating these composition functions. Okay. All right, so given that f of x equals 2x minus 5 and g of x equals x squared minus 3x plus 8, find the following, f of x. Okay, so you're putting f into itself where you see x. So this is going back into itself where you see x. Okay, f of x is 2, and then in for x goes f of x, 2x minus 5, minus 5. So again, this is the only new piece. You're putting f of x in for x of f of x. F of x equals 4x minus 10 minus 5. F of x equals 4x minus 15. And there's your composition. Okay. Let's go to the next one. Given that f of x equals the square root of x and g of x equals x minus 3, find f of g of x and g of f of x. Okay, so we're going to start with f of g of x. And again, moving right to left, g is going to go in for f. Okay, g is going in for f. So we're going to take that square root and put it underneath. Now, since there's nothing else algebraically we can do with that, that's it. That is f of g of x. Okay? G of f of x, we're taking f of x and putting it in for g. So this becomes the square root of x. Oops, get a little ahead of myself there. Square root of x minus 3. Okay, so they are different functions, and that's the composition. Okay, so let's give this one a shot. I've got f of x equals 1 over x squared, and g of x equals 5 over x. Find f of g of x and g of f of x and the domain for each. Okay, I told you guys we were going to be doing a ton of work with domain. This isn't going to go away. It's going to stay with us throughout the entire year, so you really have to get comfortable with these. All right, so let's start with f of g of x. So we know g is going to be going into f. G into f. So we get 1 over 5 over x minus 2. And let's talk about the domain for that. Now, we're dealing with a fraction here, okay? So we know some things about fractions. We know that we cannot have 0 in the denominator of a fraction. So what we need to do is we need to figure out what value of x would make this undefined. So we take that denominator and we set it equal to 0. Okay? We solve for x by adding 2 and cross multiplying. And we get a value of 5 halves. Okay? So we could state our domain as every single value except for 5 halves. So we could say negative infinity to 5 halves, union 5 halves to positive infinity. And there's your domain. Okay, I want to get the other half of this problem done. I know I'm going to be a little bit over. I apologize. Okay, so now we want to find g of f of x, and I'm going to make this go away. Okay, so f is going to go in for g now. We get 5 over 1 over x minus 2. And this is a complex fraction. I don't like the way it looks. It doesn't make finding the domain very easy. So what we're going to do is we're going to fix that. We know that 5 is the same thing as 5 over 1, and then 1 over x minus 2. This is a complex fraction. We know how to deal with complex fractions. We're going to take and we're going to multiply by the reciprocal of the denominator, which is going to give us a value of, or an expression of, I should say, 5x minus 10. Okay? 5x minus 10 is a linear function. It's a straight line with a y-intercept of negative 10 and a slope of 5. So finding the domain for that is very simple. Your domain is going to be everything. There's nothing that you can plug in for this x that's going to make this function undefined. No vertical or horizontal or slant asymptotes. Okay? So your domain here is everything from negative infinity to positive infinity. Okay, so the next lesson will be dealing with decomposition of functions. So we will talk about that in the next video. All right, thanks guys. Sorry about going over.